First, I would like to express my sincere appreciation for the local organizers, as now they stand there, to choose this very, very special, very unique place for our workshop. I think it's a very good place for us to share our recent research result also. Perhaps it's a very nice place for us to create some new ideas in this very, very special time. Today, I would like to talk about this topic. Simply, it's about very high cycle fatigue of titanium alloys. And my talk contains 6 parts, but I will focus or concentrate on these 2 points. One is specific crack initiation, and the second is nature of rough area region. First, I would like to say something about very high cycle fatigue, and especially for the behavior of very high cycle fatigue for high stress steels. And these 2 figures are perhaps the earliest result reported in literature in a very early time of 1980s to show that very high cycle fatigue behavior, it means that fatigue varies beyond 10 to 70 cycles of loading, and the load is quite low, below conventional fatigue limits. And for this area in very high cycle fatigue regime, crack initiation always from the subsurface instead of surface crack initiation. And later, it is summarized as the SN curves for very high cycle fatigue is a type of stepwise or twofold. The first one is due to surface crack initiation, and the second one is due to subsurface or interior crack initiation. And this, I think, is a very typical crack initiation morphology to show a subsurface crack initiation with a feature called fish eye. And in the initiation spot is always due to inclusion, and there's an area called FGA's fine granular area surrounding the crack origin. And we obtain that for high stress steels, the stress intensity vector range for a region of FGA, the size is not large. It's about tens of microns. This value is between 4 and 6 megapascal square meter. And we also collect a large number of testing data from literature to show that these data of delta K TH or delta K FGA stress intensity factor for this small region is between these 2 bounds, 4 and 6 megapascal square meter. And then we propose that the size of FGA is a kind of characteristic region of crack initiation for very high cycle fatigue. And the size of FGA we call is a characteristic dimension. And for this region, the fatigue life, or I would say the fatigue life for crack initiation due to the region of FGA, the size is only tens of microns, is more than 95%. So this small size is so important that it will consume more than 95% of total fatigue life. So we ask, what caused the formation process of this small area during crack initiation? And then we very carefully observe the crack initiation region on both fracture surface at the same point to show that in these 2 surfaces, the crack initiation area of FGA is a layer of nanograins, and the grain size about 50 nanometers. And therefore, we propose a model called numerous cycle pressing to expand this process. It is due to the pressing between the two crack surfaces, and also assisted by the crack closure and the relaxation of residual stresses to cause this type of morphology of rock surface called FGA. So this is for high strength steels. And for for titanium alloys, this is almost the first data reported in literature, or also in 1980s, to show fatigue failure may happen beyond or after 10 to 7 cycles of loading. And in this part, cracks are almost initiate from the interior or subsurface of specimen. And also, this is one of the very typical SN data for titanium alloy. And this is the morphology showing is also it's a morphology of fish eye and something like a bright region of crack initiation. We call this rough area. And for titanium alloy, the initiation spots is not due to inclusion. It's due to some type of something like a cleavage initiation from alpha grains. So it has a kind of facet morphology at the crack initiation point, initiation spots. So we try to further answer 3 questions. What is the behavior of faceted crack initiation for titanium alloy? And what is the characteristic dimension of crack initiation and the relation between this dimension with crack initiation, and also what's the mechanism or what's the nature of a rock area is very important. So in this presentation, I will try to talk about these 3 points. Okay, then I will mention the material and the SN data of this titanium alloy TC4 we used. And it's a kind of bimodal microstructure with primary alpha grain and also the laminar structure 50 and 50. And we use ultrasonic fatigue testing and the stress ratios from -1 to 0.5. And we use 2 types of specimen. This for -1 stress ratio testing. This for testing with mean stress, meaning the stress ratio other than -1. And this is the excellent data for our testing. The important thing is we choose 3 specimens, 2 from -1, these 2 ones is blue and red point, and the other one is from 0.5 stress ratio, the purple one, for the further examination. Okay, the 3rd point is faceted crack initiation. Again, we observe that crack initiation is from the interior of specimen with facet morphology is 0.1 stress ratio, and another one is 0.5 stress ratio. Is from subsurface. We call is surface with facet, meaning it's a surface area, but there's a subsurface facet there. This enlargement to show this type of morphology. And also, there's a type of we call multi-sites initiation, and especially for high or the stress ratio of positive stress ratios, this 0.1, this 2, and perhaps the third one to cause this type of crack initiation. And we measure the size of facets located in the initiation region, and also compare the alpha grain size distribution. And we may see that for the facet distribution and also the alpha grain distribution are almost consistent with each other. And also the further examinations from the specimen is from the cross section just underneath the surface to show some initiation phenomenon of the cracks. And then we propose this type of crack initiation process mechanism. The first is the cleavage of alpha grains and then coalescence of the faces, and also the vein crack formation or coalescence together to form a vein crack. This for the facets crack initiation. And then we are further trying to investigate the region of rough area. This is the crack initiation area there, and this also is a fisheye morphology, and the RA is due to the cleavage of the alpha grains, and this the enlargements of the crack initiation spots to show this type of morphology. And this is -1 stress ratio, and this 0.1 stress ratio, and this -0.1 stress ratio. And very similar to the case in the high stress steel, the size of the RA is somehow stable, or there's a relatively small range for RA size, and this for fisheye size is quite a large distribution area or range. And also for the delta K is stress intensity factor range for the RA region is quite stable between 6 and 9 megapascals per square meter. This value is almost consistent with the value of the crack initiation in vacuum for titanium alloy. And then we try to estimate the fatigue life consumed by the RA region. And the method is we obtain the total fatigue life, and we may obtain the life from this eye to fisheye, and also from fisheye to the final critical site. And then we are able to obtain the initiation life. And this is the result. So in the very high cycle regime is more than 95%, very similar to the case in the high stress steel. So the RA region is so important, like the case in the high stress steel. It is the RA region may consume, or will consume a large number of fatigue life, and also the value of representative parameter of delta K RA is quite stable. So it is a characteristic region, and also is a characteristic dimension for fractionation for titanium alloy. So we are again to try to examine the detailed information of the RA region. And I mentioned we choose 3 samples, 3 specimens. One is -1 failure in a very high cycle fatigue regime, and this RA region, and this area is a location for fifth sample preparation. And fifth sample is very small. The thickness is 80 nanometers. And then this is the TM morphology to show the microstructure of the titanium alloy. And we see that there's a layer of fine microstructure, and the thickness is between 800 to 1500 nanometers. And the SAD is selected area diffraction, showing the type of fine grain diffraction, meaning that in the small area of 250 nanometers, there are several grains inside. It's a type of nanograins. But away from this surface is a type of isolated spots. It's a single grain diffraction. It's only one grain in this area. It's a coarse grain microstructure. It is the microstructure in this area. Again, we examine the second specimen, also in the -1 straight ratio, and this one is in the 9.99, 10 to 9 cycles of loading, and location of fifth sample, and also to show this type of morphology similar to the previous one. So we may say that there's a nanograin there in the I region, originates from two types, both types of equiaxed or microstructures. Because I mentioned this type of specimen contains two groups of microstructure. One is alpha grains, equiaxed alpha grain. The other type is lamellar structures. And you see, this sample is something like nanostructures, and the previous one is a type of equiaxed alpha grains. So for both type of microstructures, the I region may also present nanograin phenomenon due to this type of process. And then we further examine again for these two specimens, also the indexes of diffraction to show their HGP lattice. And also we measure the grain size, and the average is about 105 nanometers. And this is very close to the fracture surface. It is away from the surface. Within the I region, you may see that this is a little bit increase of the grain size. Here, close to the surface, the grain size is even smaller. And then we observe the location outside the I region, but within fish eye. And very interesting or very important, you see, we cannot observe the fine microstructure layer in this area, the fracture surface. You see, the diffraction pattern is a very nice isolated spot, meaning just one grain inside. There's a coarse grain microstructure. And even for lamellar structure and also equiaxed alpha grains. So no grain refinement in this area. And again, I mentioned we took 3 specimens. This is the third one, 0.5 stress ratio is inside this initiation region, and the fifth sample is there. You see very nice TM photograph showing no fine microstructure evidence, and the deflection is also coarse grain pattern. So no grain refinement for this type of situation. And then I will go to the conclusion. The first one is crack initiation is a very is a characteristic feature for this alloy. And the faceted crack initiation is due to the cleavage of grains, and then the growth and coalesce of the facets, and then to form a main crack. And the eye region is a characteristic region, and also is a characteristic dimension of high cycle fatigue. And this area will consume more than 95% of fatigue life. And the nature of eye for negative stress ratio is a layer of nanograms and thickness. So this is 800 and 1,500 nanometers, and the grain size is 100 nanometers. Sorry for this. And the mechanism of rock area is we call numerous cycle pressing due to the contact between the two crack surfaces and assisted by the crack closure and the addition of residual stress. So that's the end of my talk. Thank you very much.